Okay, class. So this is the performing of these four exercises that deal with the concepts of kinetic energy, and the first two for kinetic energy and the last two for potential energy. You're gonna see how simple they are. So let's see. Exercise 1 says the following. An object of 3 kilograms has a velocity of 4 meters per second. Calculate its kinetic energy. Okay, so basically I need to know what kinetic energy is, and that's defined as 1/2 times the mass times the velocity squared. And then basically all I need to do next is substitute these two values. If I know the mass and the velocity of an object, I can calculate its kinetic energy. So it's just 1/2 times the mass, which is 3 kilograms, times the velocity to the square. And the velocity they're telling me is 4 meters per second to the square. So that's it. All I need to multiply is 1/2 times 3 kilograms times 4 meters per second to the square. So let's multiply all the numbers first. 1/2 times 3 times 4. Just remember that 4 is elevated to the square. That's the first thing you have to do. Elevate this to the square. So let's multiply all of this then. Use your calculator. And you're gonna get 24. 24, what units? Joules. Because energy, whether it's kinetic or any other type, will always be measured in joules. That's it. The kinetic energy of this object going at this velocity is 24 joules, period. Exercise number 2. We have an object. Well, an object is known to have 400 joules of kinetic energy. So we already know the kinetic energy of this object. It's going to be 400 joules. What is its velocity? If we know that its mass is 2 kilograms. So if we know the kinetic energy of this object and we also know its mass, can we know its velocity? Yes. Why? Because if I make use of the formula for kinetic energy, which is this, right? Then you can see that we can input this value in here, which is the kinetic energy, 400 joules, equals 1/2 times the mass, which is 2 kilograms, times the velocity squared, which we don't have yet. But being this an equation with just one variable, which is the v, we can isolate it. So let's do that. First, I'm going to multiply this 1/2 times 2 kilograms. When you multiply this times this, you will get 1, right? Like that. Okay, and then we just isolate v squared by dividing both sides over 1 kilogram, like that. And finally, we just take the square root from both sides. So the square root of 400 joules over 1 kilogram is going to be the same as the velocity. So basically, guys, like I often tell you, if you want, at the end, when you perform the operations, all the arithmetic, you can forget for a moment about the units. Just perform the square root of 400 over 1, which is 400, right? 400 over 1 is 400. Let's just take the square root of 400. What are we going to get? We're going to get 20. So let me conclude the problem right here. We're going to conclude that the velocity is 20 meters per second. And that's the result for this exercise. Exercise number 3. Now these ones deal with gravitational potential energy. So calculate the gravitational potential energy of a particle which has a mass of 3.5 kilograms and is positioned at a height of 4 meters above the ground. So we have the ground, we have a particle, and we know that the height with respect to the ground of this particle is 4 meters. So the height is 4 meters. There you go. We also know the mass of this particle, which is 3.5 kilograms, and the height is 4 meters. And we know the value of g because that's a constant. It's 9.8 meters per second squared. And we have all the ingredients to calculate the gravitational potential energy, which is symbolized with a U. And that's equal to mass times gravity times height. So the potential energy is equal to 3.5 kilograms, which is the mass, times the gravity, which is 9.8 meters per second squared, times the height, which is 4 meters. So once again, let's multiply all the coefficients, this number and this number and this number. Forget for a moment about the units. You don't have to multiply them because we know. I mean, why am I telling you this, guys? Why am I telling you to ignore the units? Because we know that as long as you are using official units, kilogram, meter, and second, as long as you are using those units, the final result for the value of the energy will be given in joules. So forget about this for a moment. This and this and this. Forget about it. Just multiply the numbers. Let's multiply 3.5 times 9.8 times 4, and we're gonna get 137.2 joules. So that's it, guys. This is the gravitational potential energy of this particle positioned at 4 meters with respect to the ground. And finally, exercise number 4 is the following. We know that a particle of 10 kilograms has 1000 joules of, I should have written gravitational potential energy. I forgot the adjective gravitational potential energy. Can we know at what height it is placed, the particle? Let's see. So we have the ground, we have the particle positioned some height above the ground, which we don't know. At this point, we don't know this height. The only thing we know is the mass of this particle, which is 10 kilograms. And we also know how much gravitational potential energy this particle has, which is 1000 joules. And as always, we know the value of G, which is a constant, never changes. I mean, never changes when you are at ground level. On the Earth's surface, this is the value. Okay, so can we know at what height? Can we guess H, given that we know these things? Yes, because if we write the formula for the gravitational potential energy, we're gonna write this, right? And basically just substitute the gravitational potential energy, which is 1000 joules, equals the mass, which is 10 kilograms, times G, which is 9.8, times the height. And as you can see, guys, this is an equation which only contains one variable, the height, and therefore we can solve it. We can just isolate the height. The isolation will be the following. You have to divide both sides over this factor and this factor, and you will get this expression. That's it. I just isolated H, and that's it. All I need to do is divide the 1000 joules over the product of these two quantities. Once again, forget for a second about the units. Don't pay attention to them. Just perform the arithmetic. 1000 over the multiplication of 10 times 9.8. So let's perform that in the calculator. And we will get that the height is equal to 10.2 meters. Official units, remember, meters. So there you go. That's how we can find the height of this particle, given that we know its gravitational potential energy. So that's it, guys. We're going to start with these 4 exercises, very simple 4 exercises, just to get familiar with kinetic energy and gravitational potential energy and their formulas, which is this and this for kinetic energy. And remember, kinetic energy is the energy that a particle has because it's moving, because it has velocity, and the gravitational potential energy is the energy that an object has, even if it's not moving. You see, you can have the object at rest, but it's the energy that is just waiting to be released. If you let go of this object, let's suppose that you're holding it with your hand, okay? So at this point, this object has 1000 joules of potential energy. And if you let go, if you move your arm and let go, then that energy, which is accumulated at this point, will be able to perform 1000 joules of work on anything else that is here at ground level, right here. Okay, guys, so that's how this works, and see you later.